Does everybody see what's up on the screen there? What does it say? I only heard from one person. Oh, well, I still only heard, so, okay. If you just kind of put it under your breath, then I won't hear it way over here, so. Okay, yes, molecular formulas. So yesterday we looked at empirical formulas, and the key there is the ratio. You guys got passes? All right, thanks. All right, pass for Mason.
Both of our names on there.
Oh, and Gavin, okay. And there's Avion. All right. Avion, do you have a pass? I'm just kidding. All right. There are no bells today. There are no bells today, so just be aware of that. You know, so the end of the period will be 9:09. There won't be any bells tomorrow either, so know the schedule for Wednesdays. Next 2 weeks, no bells because of AP exams. Now those are actually happening in the pods, so as far as I know. So I don't think you'll actually have to worry about disturbing anybody, but the bells would, because they can't turn them off for one part of the building and leave them on for another. So as much as I'm sure that they would like to. All right, let's see here. Okay, so again, yesterday we looked at empirical formulas, and that was all about the ratios between the masses. So first we did percent composition, where you know, starting from the formula, you can use the periodic table up there and or in your books, those of you at home, the end of your books, and you can get the masses, and then you can fog your glasses. No, that's not what it is. You can get the masses, and then you can figure out what the total mass would be, do a little division, multiply by 100%, and there you go. There are your percent composition. Working the other way around, backwards, good morning, Garrison, you can get the empirical formula from that. But how is it you're going to know what it actually is? How do I know that CH2O is what I'm talking about? And I'm not talking about glucose. Now, of course, if I'm in the lab, I can tell glucose from formaldehyde. It's quite easy to do. What would be one test? And never use your tongue. What would be one test to know whether it is formaldehyde or glucose, or fructose for that matter? How would I know? Formaldehyde versus fructose or glucose. It's the same formula. No, if I'm in the lab and I have something in front of me, I've analyzed it and I know the ratio is CH2O. How do I know? Okay, now I need to choose between formaldehyde and glucose. How am I going to know that? Let's see. I got one in the chat. Okay, there's one idea: how it reacts with water. All right, how it reacts with water. How does formaldehyde react with water? Okay, how does glucose react with water? It dissolves, right? It starts out as a powder. So we don't even need to bring water into it in this case, although reacting with water is a fine test normally. One is going to start out as a powder, one is going to start out as a liquid. Also, what else do we know about formaldehyde? Let's say that we have it in a beaker, and the beaker is open at the top. Yeah, it's going to stink. There's definitely going to be an aroma, an odor, a stench, whatever word you like to use. Now, it's going to be a bit more difficult if I have two white powders, and I know that maybe one is fructose and one is glucose, because they both are going to have the same molecular formula. We're not even to the molecular formula yet. Let's figure out how we're going to do this. Okay, ethine and benzene have the same empirical formula, CH. And we saw CH yesterday as well. acetylene. And what was the other CH? It wasn't benzene yesterday. It was acetylene versus not peanut butter. Anybody remember? Well, I got to see it a few times. You only saw it once. So that's true. It was packing peanuts. Packing peanuts. Yeah, packing peanuts. Or polystyrene. Polystyrene foam. Basically the same thing as your old-fashioned coffee cup, that you can break apart into little white bits that like to float in the ocean forever. Anyway, but this is benzene. Benzene is very different. Ethine, which is acetylene, and benzene do have the same empirical formula. CH and C, the molar mass is going to be 13. All right. For the empirical formula. However, the molar mass for one acetylene is 26, while for benzene it's 78. Huge difference in molar masses. Well, how do I know how many particles I have in there? How can I possibly know if I've got, 1 mole of benzene, or maybe I've got 3 moles of ethine? I can measure the mass, but how do I know the molar mass of my unknown that's sitting there? Well, we'll get to that. Now, for comparison's sake, methanol, which is also CH2O, not the same as formaldehyde. That's not right. No, methanol isn't CH2O. It's, no. It's formaldehyde. Sheesh. Okay, formaldehyde. CH2. Methanol is going to be CH4O, not CH2O. Sorry about that. Anyway, so formaldehyde, which is what CH2O is, and the point of that is it's 30, which it is. If you add 12 and 16 and 2, that's what you get, is 30. And that literally is the molecular formula for it. But ethanoic acid, or acetic acid, vinegar, basically, is going to have the same ratio, 1 to 2 to 1, and glucose is 1 to 2 to 1. But your masses are very different, your molar masses. Again, for these things, you can look and see, okay, is it a gas, like acetylene? All right, acetylene. And acetic acid or vinegar. There we go. All right, and glucose is brain sugar. All right, brain sugar. You can see, like in real life, you would be able to see, well, okay, powder, gas, these 3 are liquids. And then to distinguish between these 3, you could smell them. Waft. Never stick your nose right into a jar, okay? But you could waft it. but that's perhaps there are lower beings in the lab that you've sent there, and they're just sending you information. You still have to do the analysis, and you have to figure out what it is you have. Okay, so and again, same thing here. I'm not going to bother fixing this right now. Methanol. See, I knew that they would figure it. Yeah, methanol. Now, formaldehyde. I will fix that. That bothers me. I did that. All right. Okay. Anyway, you have those molar masses, and they are going to be quite different from each other. Again, though, how do you know how many moles you have? All right. Formaldehyde, ethanoic acid, and glucose do have the same formula. Either it's the same or it's a multiple. It's going to be a whole number multiple. So once you have the empirical formula, which requires those ratios and being careful with that, if you know the molar mass, then you can figure out what the molecular formula is, okay? And so the empirical formula, so not the molar mass, but the empirical formula mass from its empirical formula, and then you divide the experimentally determined molar mass by the empirical formula mass. So again, this is what you just did, okay, yesterday, okay? And this is something new today. And then that quotient gives you the ratio, all right? So you can multiply, it's the multiplier. So it's going to be times 2, it's going to be times 6, it's going to be times 3, whatever it is. And then you get your molecular formula. So here we have a calculation. The molecular formula of a compound is molar mass is 60 grams per mole, and the empirical formula is CH4N, okay? Molecular formula of a compound is molar mass is 60 grams per mole, and empirical formula is CH4N. So we already know that that's the empirical formula. We don't have to figure that out right now. But what is the total, if I literally had CH4N, what would that mass be? So you've got to use the periodic table, or you've got these memorized. You got these non-metals memorized. What's that going to be? Either one. Use the periodic table. You got to add those together. Say again. Yeah. You're adding 4 H's, you're adding 1 C and 1 N. $30. Austin, you with us? Yeah. Okay. 30. All right, so C is 12. Each H is 1, so there's a total of 4. And again, I'm rounding to the nearest whole number just for making this quick, because you're going to get a whole number ratio. So whole numbers, those are generally very few significant figures. So you can just do it kind of in the quick and dirty way here. So each of those is 4, so you add those to the 12 we had from carbon. That's 16. And then you add nitrogens, and that's going to be 14, right? So 16 and 14 is 30, right, exactly. Now 30 goes into 60 how many times? People at home? You're going to think there's only one person really at home. Thank you, one person, for giving me that answer. Yes, it goes into 60. 30 goes into 60 twice. All right, so then you just multiply the 2 through there. And again, this is the long way of doing it. 12.0, 4 times 1.0, plus 14.0 is 30.0. 60 divided by 30. Okay, again, molar mass divided by 30 is 2. Multiplied by 2 is C2H8N2. C2H8N2. Now, does anybody know what that is? C2H8N2. It's going to be one of your amino acids that float around in your body to help make your proteins. I'll let you try to figure out what it is. Okay, now does it make sense? Well, the molecular formula does have the molar mass of the compound, right? We know that by definition, but we could go and calculate it out again. 28 plus 8 is 36, plus 24, yep, 60. And, you know, it's still in the same ratio, so sure. So what do we need to know in order to figure out the molecular formula? The molar mass. You've got to have the molecular mass of that. Now, how do we figure that out? If we've got something in front of us, how do we know what its molecular mass is if we don't know what it is? If I don't know, okay, this could be acetone, it could be formaldehyde, how do I know what it's going to be? How do I know what the molecular mass is going to be? There's a method we haven't gone to yet where you can figure out the molar mass of a compound based on reactions. And reactions are what we're headed towards, but in this chapter, we're just figuring out what the formulas are and how they work and how to calculate those. So just for now, file on the back of your mind that there's a magical way to figure out the molar mass. And then we use that compared to the empirical formula, which you can calculate. just based on mass and volume and that sort of thing. And then you figure out the ratio, and now you can have the molecular formula. So to sum up, the percent by mass of an element in a compound is the number of grams of the element divided by the mass in grams of the compound, then times 100%. So that's the percent composition. You take the element divided by the whole compound, the part divided by the whole, times 100%. Okay? Then you can figure out the empirical formula of that compound working backwards. And when you get that empirical formula, you can figure out the molecular formula as long as you know what the molar mass is. So, there we go. Okay, so some words again: percent composition, empirical formula, and now the mole. The mole, okay, you got to have the percentage composition, the empirical formula, and the molar mass. But how are you going to? You have to have something. You can't start with nothing. You can't just have a beaker of some clear, colorless liquid and say, you know, what is this? Until you've got more pieces in your toolbox. But now at least you do have a toolbox. You can say, well, if I knew that, you know, such and such percent of it was oxygen, and such percent was carbon, and such percent is hydrogen, and such is nitrogen, then I could say what the empirical formula is. And in the future, having done some reactions, I'll know how many moles there are, and the molar mass then is going to be the number, the total mass I had divided by the number of moles I had, and then I can figure out the molecular formula. It can be done. It can be done. But you're not there quite yet to figure out the molar mass. But if you're given the molar mass, then you're going to be in good shape. All right. The rest of this time, I'm going to allow you to work on what I've assigned you. You've got at least one skill sheet you probably didn't do before today on the molecular formula. And please do ask questions as you have them.